All right, good day, everyone. Welcome back to class. Today, we want to look at a very important question in the topic frictional force. Frictional force. Please don't skip any part of this video. Ensure you watch this video from the beginning to the end in order to get the full explanation of everything in this place. Because I'm going to be using this question explaining the full topic, frictional force, so that you will be able to tackle other questions that might be coming up from this same frictional force topic. So there are three components that majorly something like acts when we have what we call frictional force, what we call normal reaction, coefficient of friction, and the major frictional force. We also have what we call angle of friction. What's what we call what? Angle of friction. Angle of what? Friction, which is actually the angle between the normal reaction and the resultant reaction. So we have all these things. So I'm going to be explaining most of these stuffs. So that's why you should listen. Don't skip this video. Don't say maybe you know this topic. No. Just relax, watch, because you're going to gain something new from this just single question. I'm going to use this single question to explain so many things regarding this topic. Ensure you like, share to others, and that is above all, subscribe to this channel, because that is very, very important to us. So you also like this video or share, because you are helping us as you are doing that. It won't cost you anything. You're not going to use any money for it. It will not cost you anything. Please try your best to do it. So they said we should calculate the maximum frictional force which acts when blocks of mass 2 kg rest on the rough's horizontal surface when the coefficient of friction is 1.5. This coefficient of friction is not constant. It varies from one surface to the other. So some surface might have 0.2, some surface might have 0.1. This surface is having the coefficient of friction, and this is 1.5. And take note, this coefficient of friction don't have unit. I will show you why this coefficient of friction don't have unit later. That's why it's just 1.5. So the options are 8.2 newtons, 10.4 newtons, 29.4 newtons, 18 newtons. So which of these option is the actual correct answer to this problem? So what we're going to do now, we're going to look at this question. We're going to explain in details. So let's go. All right. Before I go into this major calculation, now the first thing is to teach you guys what this concept called frictional force entails. Now, there is a force that tends to act as a separate between two surfaces that is in contact. Now, when two surfaces in contact, there is a type of force that is developed, and it's called frictional force. Now, look at something. Now, there is a frictional force, something like we have what called static friction, also we call dynamic friction. Now, when a body, the friction or the force that the body will overcome before it starts to move, that is a friction. Then when a body is moving, the force is still something like overcoming. It's also a friction. So one is static, the other one is dynamic. Now, look at something also very important. Now, let's say we have a surface. Let's say we have a table. This is the table, and this is the surface of the table. Now, if you drop a box here, now between the reason why this box will stay in this place is because there is a force holding the box that is acting between the surface of this box and the surface of this table, and that is the frictional force we are talking about. And the reason why you can stand without falling, without slippery, is because of this same frictional force. This is why this box can stay in this place now, that slowing downward or moving down or slipping from each side, because of this same frictional force. Now, when this box is here, the weight of the box will be acting downward. Because there is what we call center of gravity or center of mass, where the whole weight of a body do act on. So automatically, this body is going to be, the weight is going to be acting downward. The weight is going to be acting downward. So this one will be the weight of the body, And weight is the mass times acceleration due to gravity. That is weight. Now, when this weight is acting downward, there is what we call normal reaction. And what is the meaning of this normal reaction? The normal reaction is the one that this surface is given to this weight and is equivalent. If it is not equivalent to this weight, or if that normal reaction don't balance this weight, this body will not be able to stay. It will break this surface and fall down. So the normal reaction will be acting upward. So this is the normal reaction of this surface to the weight of this body. Now, the reason why this body will not fall out of this surface is because of frictional force that may either be acting this way or this way, depending on the place the body is moving to. So the normal reaction is moving vertically, then the frictional force is acting horizontally. So you take note of that. So I have mentioned two things now. I've mentioned frictional force, then I've also mentioned normal reaction. Normal reaction. I mentioned those two things. Remember, this one will be moving. If a body is, let's say we have a body with this nature, the weight of the body is going downward. Let's say the body is on top of a table. The body is going downward, then the normal reaction will be moving, acting upward. Then the frictional force will either be acting this side or this side. Maybe we'll be acting at an angle safe, no problem. But the frictional force will be acting in the horizontal direction. So we can just say, what amount of force will just cause this body to move? The only force that can cause this body to move horizontally is a force that can balance the frictional force. So if I ask you, what is the force that will just cause this body to move? Is equal to the frictional force. Any force equal to the frictional force can cause this body to move. So take care of that. It's also very, very important. So I've mentioned two things. I've mentioned the frictional force and the what? The normal reaction. Then there's another thing also very important, and it is called mu. It's called mu. And we'll call it the coefficient of friction. That's what we call it. The what? The coefficient of friction. So these are the three things we use mostly in this topic, frictional force. The frictional force, normal reaction, and the coefficient of friction. Now, what's the meaning of the coefficient of friction? The coefficient of friction is the ratio of this limiting friction, the ratio of this friction to normal reaction. The ratio of what? The frictional force, and also take note of this. Very, very important. The coefficient of friction is equal to what? The ratio of frictional force to what? To normal reaction. And it does not have unit. Why? Because frictional force is in Newton. Normal reaction is also what? In newtons. Newton cancels newtons 1. This one is something like, it is dimensionless. It does not have unit. This stuff is dimensionless, and there's no unit for it. Also take note of that. So now, from this question we want to solve, how are we going to go about this question? Because we are looking for, they say, what is the maximum frictional force? That's what we are looking for. We are looking for frictional force. That's what we are looking for. Remember, I told you guys that coefficient of friction is what? The ratio of frictional force to what? To normal reaction. So if I want to make frictional force a formula, I can just use something to multiply this, so that the frictional force will now be equal to normal, this coefficient of friction times what? Times normal reaction. So this is another important formula you should also note in this place. So take note of this thing, also very, very important. Now, if a surface, let's say we have a surface, is maybe absolutely smooth, for an absolute smooth surface, a surface that is absolutely what? Smooth, the frictional force of that surface will be equal to 0. There's no frictional force for that surface. A surface that is something like, it is 100% smooth, the frictional force there will be 0. So if the frictional force is 0, then coefficient of friction will also be what? 0. So also take note of that. It's very, very important. Now, from this question now, the body was having a mass of what? 2 kg. Body was having a mass of 2 kg. Then the coefficient of friction was given as what? 1.5. Given as what? 1.5. So let me just draw it so that you see it. I just want to use straight formula so you see it. Look at what we're having. We're having a body of, the mass of this body is what? Is 2 kg. That is the mass. So to get the weight now, we'll use this man to multiply 9.8 because our acceleration due to gravity is ranges from 9.8, 9.81, 10 meter per second square. That's what the acceleration due to gravity we use here as the something like the constant for this g. Remember gravitational acceleration due to gravity, which is either 9.8 or 9.81 or 10. If they gave you 10 in the question, you can use 10, no problem. But this in this question, I'll be using 9.8. I'll be using 9.8 for this acceleration due to gravity. Now, what do we need the acceleration due to gravity for? What do we need this acceleration due to gravity for? Because before you can convert this mass to force or to weight, you must use it to multiply acceleration due to gravity. Look at what I'm trying to say. For example, if you have mass, and I said, what is the weight of this mass? Use the mass to multiply acceleration due to gravity. So anything that has something like anytime you have mass and you want to get the weight out, use the mass to multiply what? G. That will give you the weight. So mass is this mass is in kilogram, then this weight is in meter per second square. So kilogram meter per second square is equal to newtons in terms of dimensional analysis. So that's how the stuffs are done. So that's what I'm trying to say. So for me to get this stuff now, I'll just put the mass here. I'll put the mass here. I'll put the mass here. So to get the mass, I'll just use 2 times this 9.8. That'll give me 19.6. This mass now is now in newtons. That is now weight. Then this is the normal reaction will now be going up. Then the frictional force will be going, let's say frictional force will go to this side, that is frictional force. The frictional force. So from a static equilibrium now, we can say the sum of the forces in the y direction is equal to 0. Or upward forces must be equal to downward forces. Look at this one is going upward. So that's arrow is equals to downward forces, which is this 19.6 newtons. So we have gotten normal reactions now, which is 19.6 newtons. So anytime you see a question like this, so just get your normal reaction. Just use the mass to multiply gravity. That'll give you the normal reaction, which is 2 times 9.8. That'll give us 19.6 newtons. So that is normal reaction. And I told you the frictional force is equal to what? The coefficient of friction times what? Times normal reaction. That'll give us coefficient of friction is 1.5 times 19.6. 19.6. So let's do this to see the answer we are going to get. 1.5 times 19.6. 1.5 times 19.6. So we're going to have 29.4. That'll give us 29.4 newtons. So this will give us the frictional force. This is the frictional force, the molecular frictional force of this body. So please take note of that. It's very, very important. All right. So don't forget. If you have a surface, I have a mass on top of this surface. The weight is acting downward. The mass reaction will be acting upward. Then this is why this weight will not slip either to this side or to this other side because of frictional force. Then look at this thing. If a force, let's say a force P is moving this body to this side, and if the force is moving this body to this side, frictional force will be going in the opposite direction of this force that is trying or that is moving this body. So frictional force will be going to this side. Now, before this force can move this body, it must be greater than this frictional force. If this force is less than this frictional force, the body will not move. If they are equal, it will not still move. But if this force is now greater than this, the body will now just start moving, or motion will occur. So please take note of all these stuffs. They are very, very important. Thank you.